Day 13. Okay, so we have two fractions. We already have a common denominator, so we can combine them into a single fraction. And so we get 9 over t. Number 5, we have a common denominator. So I'll just have 11 minus 1, which is 10 over 5x. But then we can simplify. 5 goes into 5 once and into 10 twice. So our final answer ends up as 2 over x. We already have a common denominator, so I make a single fraction with this denominator. I have 5x plus 4 plus x plus 1, which comes out to 6x plus 5 over 6x plus 5. And everything on the top and bottom cancel, so I end up with 1. Okay, so we have a common denominator, so I just combine the numerators over that single denominator. But this is a simplifiable fraction because if I factor the top, that's the difference of two squares, so I get the conjugate pairs over x plus 5. And then this and this cancel, so I'm left with x minus 5. Okay, so I have a common denominator, so I can combine my numerators and put it over this denominator. But now this fraction is not simplified because the bottom is factorable. And this is a p plus 4, p plus 3 over 4 plus p. And p plus 4 and 4 plus p are the same factor, so those cancel, and I'm left with 1 over p plus 3. Notice I got rid of my parentheses on the bottom because they would be redundant. Okay, so I have a common denominator, and I can just combine the numerators over that single denominator. And I can factor the top. This is the difference of two cubes. So I have a binomial times a trinomial. Remember, the binomial are the cube root items. The trinomial is square, product, square. Okay? And I do SOAP. Same, that's the same sign. Opposite of that, always positive. And I have this over this. And now you can see that the entire factor here cancels. So it's over 1. So my final answer is simply a minus b. Okay, I'm finding the GCF. The largest number that can go into both 18 and 24 is 6. So 6 is part of my GCF. Then I look at these and I'm looking for the smallest variable part. So x squared. That's the largest that can go into either of those. And then I look at this, and y cubed is the smaller of those two. So this is my greatest common factor. Okay, when you're trying to find the least common denominator, one of the ways to do it, now if you can see that 72 is the smallest number that both 18 and 24 can go into, great, but you may not see that. And here's a systematic way of doing this. 18 equals 24 equals. So now what we're going to do is we're going to break down 18. This is 9 and 2, 3 and 3. So this is 2 times 3 squared. 24 is 2 and 12. This is 2 and 6. This is 2 and 3. So this is 2 to the third power times 3. So the least common denominator, or the least common multiple, whatever you want to call it, is going to have 2 and 3 as factors in it. And you just include the greatest number exponent. So the 2 has an exponent of 1 here, of 3 here. 3 is bigger. The 3 has an exponent of 2 here and 1 here. 2 is bigger. So 2 to the third power is 2 times 2 times 2, which is 8. 3 to the second power is 9, so this is a 72. And then when I'm finding my variable part, I use the same logic. I look at this and this. 4 is greater than 2. So I know I have to have to the 4th power. Between 3 and 5, 5 is greater than 3. So I know I need to have y to the 5th power. So this is the LCD between those two items. Okay, in this problem, these are terms, they're not factors. So this entire item is a factor. This entire item is a factor. They're different. And so we have two entirely different factors. So the LCD is just sticking those factors together. Oops. So that's the LCD. These share nothing in common. So we just put them together. Okay, before you can decide whether or not something shares any factors in common, you have to factor. So this is 2 parentheses y plus 4. And this one cannot be factored. So this one has two factors. The factors are a 2 and a y plus 4. This one has a y plus 4. This is in common. So my final LCD is 2y plus 4. Notice that this is to the 1 power, this is to the 1 power. The greatest is to the 1 power. It's another way to think about it. Okay, on the left, if I factor, that's the difference of two squares, so I have my conjugate pairs. On the right, this is a perfect square, so I have x plus 9 quantity squared. Notice we have, in its entirety, we have two different factors. We have the x plus 9 and the x minus 9. Okay, if you're looking at the x plus 9, I have an exponent of 1 here and of 2 here. 2 is bigger, so my LCD is going to have that factor with a square. And then I have x minus 9 with an exponent of 1 here, of 0 here. 1 is bigger, so I'll have x minus 9 in my LCD. So that's the LCD between the two. Okay, these two items are already factored, but this one needs to be factored as the difference of two squares. Okay, so now there's nothing has an exponent greater than 1. This is m plus n to the 1 power. This is m minus n to the 1 power. This is m plus n to the 1 power times m minus n to the 1 power. So this right here is my LCD. So the LCD is m plus n times m minus n. Okay, for this one on the left, we're going to factor, and we're going to have an x minus 3, not x minus 3, x minus 4, x plus 1. And over here, we're going to have an x times 1, 1 plus x. All right, so 1 plus x and x plus 1 are identical. Those are the same thing. So the different factors we have are that this is an entirely different factor that's different from every other one, and this is an entirely different factor that's different from every one of them. So we just, nothing is happening with an exponent greater than 1. So we just put them all together like we see it. So we're going to have x plus 1, and x minus 4. That's the LCD. Okay, so I'm going to factor this on the left. This is obviously a 2t and a t. I'm trying to get to 7, so this must be plus 5 to give me a positive 10, minus 3, and that'll get me to the 7. Here on the right, I have a t and a t. I'm trying to get to 3, so it must be a plus 5 and a minus 2. Okay, now, there's 3 different factors. Here's one that doesn't match with anything else. Here's a second one, and here's a third factor. None of these are occurring more than one time. So they're all going to occur exactly once in our LCD. So the LCD is 2t minus 3 times t plus 5 times t minus 2. Remember, it's not occurring more than once in any one of the entire originals. So even though this occurs here and here, it's only once in each of these items. So it's only going to occur once in the LCD. Okay, this first item can be factored by pulling out a 2, and we're going to be left with y plus 3. This second item is the difference of two squares, so I have the conjugate pairs. And this third item is just y. So when we look at the different factors, we have a 2 that's different from anything else. We have a y plus 3 that's showing up in those spots. We have a y, so we have a y minus 3, and we have a y. So we have 4 different factors, but none of them have an exponent greater than 1 in any one of the original items. So they're all going to show up with an exponent of 1. Now remember, you always write your monomial factors first. So 2y is going to come first, and then y plus 3 and y minus 3. So that's our final answer for the LCD. Okay, they're asking you to identify the terms. And remember, terms are separated by a plus or a minus. So the two different terms in the numerator are x squared and 4x. The two different terms in the denominator are x and 4. So that's part A. Part B, describe the steps you do to write this in lowest terms. Well, step 1, factor numerator and denominator. So I would factor, I would pull out the x in the numerator, I'd be left with x plus 4. In the denominator, I cannot factor. So step 2 would be to cancel common factors in the numerator and the denominator. So I cancel. And so my final answer would be x. Okay, so the question is, could both of these students who have these two what seem like different answers, could they both be correct? The answer is yes, they're the same answer. If you notice, this is a positive 3, this is a negative 3, so those are opposites of each other. But 5 minus y and y minus 5 are also opposites of each other. So if you have the opposite on the top and on the bottom, you actually have the same fraction. So these are, I don't know how you'd write that in words, but this is the same or equivalent fractions. Opposite in numerator and denominator. Okay, so I'm going to write these fractions down like this. And I'll put a t here and a 3t here. We have our 8 and we have our 7. Now, what I'm going to do is I'm going to first decide what the LCD is. And I can see that it's a 3t. So in order to make this one here look like a 3t, I have to multiply by 3. So I have to do the same thing in the numerator. This one on the right, I don't have to do anything. And so now what I'm ending up with is a 24 plus 7 over 3t, which is a 31 over 3t. Okay, so the first thing you want to do is find your LCD. The LCD is 12 x squared y. So now I'm going to write these fractions down again. And I'm going to, this one on the left, I don't have to change. But the one on the right, I need to get to this, I have to multiply first by 2. So I'll do that here as well. And I also have to multiply by an x. So I'll do that there as well. Okay, so now what I have a common denominator of 12x squared y, and up in the numerator I have a 5 minus 22x. And I can't do anything else. On the numerator, those are not like terms, so I can't combine anything. So this is my final answer. Okay, here I'm going to determine my LCD. These are entirely different factors, so my LCD is just the product of those two things. So here, I'll write this down again. And in order to make this here look like this, I must multiply by x. So I do that on the top as well. To make this look like this, I have to multiply by x minus 1. So I do that in the top as well. Okay, so now I have a single fraction with the denominator x times x minus 1. I'm going to have 1 times x is x, and now I'm going to take this negative and attach it to that 1 before distributing it in. So I'll have a negative x plus 1. Well, x minus x is 0, so those cancel out, and I'm left with, as a final answer, 1 over x times x minus 1. Okay, in this problem, I need to determine the LCD, and I have two entirely different factors in the denominators, so that putting them back together is the LCD. So I'll write this one, and I'll give myself some room. And I'll write this one, and I'll give myself some room. Okay, in order to make this denominator look like this, I have to multiply by an a minus 3. So I need to do that in the numerator as well. To make this one look like this, I have to multiply by an a plus 1. So I have to do that in the numerator as well. Okay, now that I've done that, I have a common denominator. And I'm just going to distribute here. So I get 3a squared minus 9a, and I'll distribute here. So I get a positive 2a squared plus 2a. And now I'm ready to combine like terms in the numerator. So 3a squared plus 2a squared is 5a squared. Negative 9a plus 2a is negative 7a over a plus 1 times a minus 3. Now I can see that this is an unsimplifiable fraction, but if you're not sure, you should always factor each side entirely and then decide if you have any common factors that can be canceled. I'm going to circle this because I can see that it's not, but if I factored the numerator, I could only take out an a, and I would have 5a minus 7. Well, neither of those factors up top show up in the bottom as well. I don't have an a in either case. I don't have a 5a minus 7 in both places, and so on and so forth. So you could write your answer like this or like this. Either one is okay. Okay, we already have a common denominator, so I'm ready to combine them, but be careful because of this minus. When I bring it into those two terms, it's going to distribute. So my common denominator will be 9y plus 7, but I'm going to have a 17y plus 3. This is going to become a positive 10y when I multiply that negative in, and it's going to become a positive 18 when I distribute that negative. So now I'm ready to combine like terms. I got 27y by adding up my y's plus 21. This is an unsimplified fraction. It's hard to see that the form it's in, but remember, in order to simplify, you got to make sure you've completely factored both the top and the bottom. There's a 3 common to both of those. So I pull the 3 out, and it leaves me with 9y plus 7. In the denominator, I have 9y plus 7. Now I can see this entire factor cancels away, and I'm left with just 3. 3 over 1, but you simplify that to 3. Okay, at first glance, it looks like we have different denominators, but we don't. I can rewrite this as an x minus 4 as long as I introduce a negative sign. So instead of 2 up top, it's a negative 2. Now these are equivalent fractions, but now I have a common denominator. So my denominator stays the same, and I simply have negative 2 plus 5. So my final answer is simply going to be 3 over x minus 4. Okay, again, it looks like we have different denominators, but I can make this one look like that by factoring out a negative. Or if I flip it around, w minus z, that just introduces a negative sign, which I can tack on right there. Negative times negative is a positive. And so this is still z. So really what I have is w plus z over my common w minus z. I want to figure out what the LCD is, but before I do that, I need to factor. So I have 5 over, I can take a 4 out, and I'm left with 3 plus x down here, minus 7 over, I can take a 3 out, and I'm left with 3 plus x. So if you look at my monomial coefficients down here, the LCD between them, so let me do an LCD here, is 12. And then this just matches up here, so, well, I like putting x plus 3, but I'll just write it the way it is, 3 plus x. So that's the LCD. So in order to make this one look like this, you have to multiply by 3. And you have to do that in the numerator as well. In order to make this one look like this, we have to multiply by 4. So I'm going to do that in the numerator as well. So this is a 15. I end up with a 15 minus a 28, and it's now over my common denominator, which is 12 times 3 plus x. So I'll simplify this and get negative 13 over this, and I'll put the negative out front. I could put the negative up on the 13, but I prefer it in the middle of the fraction. And if you wrote x plus 3 instead of 3 plus x, I think that's great, although it wasn't necessary. Okay, before you can start deciding what the LCD is, you need to make sure all of your fractions are factored. So this first one, I'll write it in black. This first one cannot factor. So we have 4x over x minus 1. Notice I'm leaving myself some space. This one is 2 over x plus 1. And this one is 4 over, and this will factor, x plus 1, x minus 1. So the different factors we have are an x minus 1 and an x plus 1. They just match up again here. None of them have an exponent greater than 1 in any one spot. So this right here is the LCD. Okay, so now so my LCD is x plus 1, x minus 1. To make this one look like that, I have to multiply by x plus 1. So you have to do that in the numerator as well. For this to look like that, I have to multiply by x minus 1. And I have to do that in the numerator as well. In this last one, we don't do a thing. So when I distribute here, I'll get 4x squared plus 4x. When I distribute here, make sure you tack this negative onto the 2 before distributing it through. And I'm going to get negative 2x, and I'll get a plus because a negative 2 times a negative 1 is a positive 2. And then I have negative 4. And this will be over my denominator, x minus 1, x plus 1. Okay, now I got to combine like terms. So I have 4x squared. Let's see, I have plus 2x minus 2. Okay, and this is all over x plus 1, x minus 1. Now, I should have written a little bit smaller. I've run out of space. I wonder if I can shrink everything down. Well, I can't. I don't think I can. No. So I'm going to try and fit everything down here on the bottom left. You know what I'll just slide this up. Well, that works. Okay. So now I can factor a 2 out of the top, and I'm left with 2x squared plus x minus 1 all over this stuff. And I can factor further. This is a 2x and an x, and it must be a plus 1 minus 1 here, and that'll equal that. So finally, the x plus 1's cancel. And your final answer is going to be 2 times 2x minus 1 over x minus 1. Before I can figure out what the LCD is, I need to factor. So let's factor the denominator of the first one. I'm going to have 15 over y times y plus 3. This second one, I have 2 over y. And the third one, I have 5 over y plus 3. So the different factors involved in the denominator are a y and a y plus 3. That's it. So that's my LCD. Okay, the first fraction I'm going to leave alone. I already have that denominator. The second one, I'm going to multiply by y plus 3. So I have to do that in the numerator as well. The second one, I have to multiply by y. So I have to do that in the numerator as well. So I'm going to end up with 15. Now I'll distribute this. So I have plus 2y plus 6 plus 5y over that denominator. I'm going to combine like terms. 2y plus 5y is 7y. And I have 15 plus 6 is 21. Now this is also not a simplified fraction because the top is factorable. I can take a 7 out and it leaves behind a y plus 3. So finally, I have to cancel my y plus 3's, and my final answer, to put it in red here, is going to be 7 over y. Okay, before I can figure out my LCD, I need to factor everything. So this first fraction is unfactorable, so I'll just leave it like this. The second fraction is unfactorable in the denominator, so I'll leave it like that. But this third fraction, I can pull out an x, and I have that. So my only factors involved in the denominators are x and x minus 2. So that must be the LCD. So this first one, in order to make this down here look like that common denominator, I have to multiply by x. So I do that in the numerator as well. The second one, I have to multiply by x minus 2. So I have to do that in the numerator as well. And the third one I'll leave alone. So I'm going to have 5x, now distribute this one, so plus 1x minus 2, and then plus 2, all over that denominator. I'm going to combine like terms. So I'll have 5x plus 1x is 6x. The negative 2 plus 2 go away, and in the denominator I have this. But now I can cancel. This x cancels with this x, so my final answer is 6 over x minus 2. Okay, before I can figure out my LCD, I need to factor all the denominators. So this first one is unfactorable, so I'll leave it like this. And notice I'm leaving some space for myself. The next one I cannot factor, so I'm leaving again some space. The third one is factorable, and it's x plus 1 times x minus 1. Okay, the only factors involved in any of the denominators are x plus 1 and x minus 1. So that is my LCD. So this first one, I have to multiply by x minus 1 to make it look like the LCD. And so we do that in the numerator as well. This second one, we're going to have to multiply by x plus 1 to make it look like that. So I do that in the numerator as well. And this last one I leave alone. Okay, so now I'm going to distribute, and I'll get 3x squared minus 3x. I'll distribute, and I'll get plus 4x plus 4, and I have this minus 6 all over my common denominator of x plus 1, x minus 1. Now I'm going to combine like terms. I have 3x squared, negative 3x and positive 4x are positive 1x, and positive 4 minus 6 is a negative 2. Now, I think that this may be a simplifiable fraction, but I'm not going to know for sure until I factor the numerator. So I'm going to slide this up a little bit. Okay, so now I'll factor this numerator, I'll try to, and I have 3x and x. Let's see, this is going to be minus 2 plus 1. On the outside, I have a positive 3x. On the inside, I have a negative 2x, and that adds up to my positive x. So down here, I have x plus 1, x minus 1. And finally, I can now see that I can cancel those, and I'll end up with 3x minus 2 over x minus 1. And notice I took away the parentheses because those would be redundant, and so I need to simplify and get rid of those. So that's my final answer. Okay, before I can figure out my LCD, I'm going to need to factor. Okay, this first one is not factorable, so I have this. Okay, I'm going to leave myself plenty of room. The second one is not factorable. That's a prime factor down there. So I'm going to do this. But this third one is the difference of two cubes. So here, let me erase this. This is the difference of two cubes. So remember, in the difference of two cubes, you always have a binomial times a trinomial. The binomial are the cube root items, so x and 1. And then we go square, product, 1 times x is x, square, 1 squared is 1. And then we'll apply the SOAP. SOAP is the same sign, opposite, always positive. So notice that this is the LCD. So what I need to multiply this one by to make it look like that is x squared minus x plus 1. And I have to do that in the numerator as well. This next one, I need to multiply by x plus 1. And I'll have to do that in the numerator as well. And the third one, I'll leave alone. Okay, so now I'm distributing this 4, and I'll get 4x squared minus 4x plus 4. I'll distribute this 1, and I'll get plus x plus 1, and then I have a minus 12 all over this denominator. Okay, so now I'm going to combine like terms. I have 4x squared sitting all by itself. Negative 4x plus 1x is negative 3x. And 4 plus 1 is 5, minus 12 is minus 7 over this. Okay. Finally, I'm going to factor this numerator to see if I can reduce. So I believe it's going to be a 4x and a 1x. I know that I'm going to have a 7 here and a 1 here. That'll give me 4 on the outside and 7 on the inside. So this has got to be a negative to give me a negative 7 on the inside. That means this will be a positive to give me a positive 1 on the outside. Okay. And now I can see I have a common factor, which is x plus 1. So that cancels. And I'm left with my final answer is 4x minus 7 over x squared minus x plus 1. Number 59, before I can figure out the LCD, I'm going to need to factor everything. The first one cannot be factored. The second one cannot be factored. Notice I left myself some room because I'm anticipating what's about to happen. The third one can be factored. Okay, so I hope you can see that this is the LCD, because those are the only two factors showing up anywhere. All right. In order to make this first fraction look like that, I need to multiply by x. So I got to do that in the numerator as well. To have the second one look like that, I have to multiply by x plus 3. So I have to do that in the numerator as well. And the third one I'll leave alone. So this first fraction is going to become, I'll distribute this, and I get 2x squared plus 4x. I'll distribute the 3, and I'll get plus 3x plus 9. And then I have the minus 6 all over this denominator. When I combine like terms, my 2x squared is just sitting there. 4x and 3x becomes 7x. And positive 9 minus 6 is a positive 3. Okay, this may be able to be reduced, so I'm going to try and factor the top. Give me some. I'll scroll here. Okay, so I have a 2x and an x. This must be a plus 3 to give me 6 on the outside, a plus 1 to give me 1 on the inside, and that adds up to my 7. And now I can see that I have a common factor of x plus 3, and that cancels. So my final answer is 2x plus 1 over x. Okay, before I can figure out my LCD, I'm going to need to factor both denominators. So this first one factors as x minus 6, x plus 1. And notice I'm leaving myself some space. On this next one, I have 2 over, and this is going to be x minus 2 squared. X minus 2 times x minus 2. Okay, so my different factors that I have are x minus 6, x plus 1, and x minus 2. But this one has an exponent of 2. So my LCD must be x minus 2 squared times x minus 6 times x plus 1. Okay, so, oh shoot, that's not true. Okay, before I can figure out my LCD, I need to factor the denominators. So I'm going to have 3 over, this becomes x minus 2 times x minus 3. That's going to add up to my 5. And notice I'm leaving myself some space. This next one, this is a perfect square. This is going to be x minus 2 quantity squared. Notice I'm leaving myself some space. So my LCD, the x minus 2 is showing up in both spots, but it has an exponent of 2 in this one on the right. So my LCD is going to be x minus 3 times x minus 2 squared. Okay. In order to make this one look like the LCD, I need to multiply by x minus 2. And that'll give me a square. So I need to do that in the top as well. To make this bottom right one look like this, I need to multiply by x minus 3. So I'll do that up here as well. Okay. Now, distributing this 3, I'm going to end up with a 3x minus 6. Distributing this, I'll tack this negative onto the 2 and distribute the negative 2, in which case I'll get negative 2x plus 6. It's a common mistake to have a minus there because people sometimes only look at that one sign, but we're distributing a negative 2 there. Okay, I'm going to do this. I know what the common denominator is. I don't want to keep writing it when I don't have to. So up top, I'm going to combine like terms, and I'll get x over, now I'm going to write that denominator. So I have x minus 2 squared times x minus 3 in either order. I don't have anything that can cancel, so that's my final answer. Okay, before I can figure out my LCD, I need to factor my denominators. So here I have 3 over, and this is going to be x plus 2 quantity squared. This is 7 over, and down here I have x plus 2, x plus 3. So my LCD is going to be x plus 2 quantity squared times x plus 3. So to make the one on the left look like that, I need to multiply by x plus 3. And I have to do that up in the numerator as well. To make the bottom right one look like that, I have to multiply by x plus 2. So this is going to be like that. Okay, when I distribute this 3, I'm going to end up with 3x plus 9. When I distribute the 7, I'll get plus 7x plus 14. I'm going to do that because I don't want to write that until I have to. So this is going to be 10x plus 23 when I combine like terms. And now I have to write the denominator because I need to show that in my answer. That's not simplifiable, so that's my final answer. Okay, again, before I can figure out what my LCD is, I'm going to need to factor. So this bottom one will factor as an x times x. Let's see, we must have a plus 2y on the outer and a negative y on the inner. I'm going to give myself some space. Minus, this one's going to factor as this must be an x plus 6y and an x minus y. Okay. And we have a 2x down here. I want to make sure that works before I move on. Plus 5x. Yeah. Okay. So my LCD is all of this stuff. It's x plus 2y times x plus 6y times x minus y. All right. So this bottom left one, I'm missing the x plus 6y. So that's what I need to multiply by in the top and bottom. This one on the right, I'm missing the x plus 2y. So I need to multiply it by that on the top and bottom. Okay, now I'm going to distribute this, and I'll get 5x squared plus 30xy. Now I'm going to take this negative and tack it onto the 2 before distributing that in, and I'll get a negative 2x squared minus 4xy. And it's all over that denominator, which I'm not going to bother to write right now. 5x squared minus 2x squared is 3x squared. And a positive 30 and a negative 4 give me a positive 26xy. Okay, now I'm going to write my denominator down. So I have x minus y, x plus 2y, times x plus 6y. Yikes, I just realized I wrote the problem down wrong. This was not a 2, this was a 3. Let's see how that changes the problem. That makes this a 3, so that when I multiply this in, I get, this becomes a minus 3x here, and this becomes a minus 6, not a 4, xy. And then when I combine like terms, this 5x minus 3x squared, this becomes a 2x squared. And 30 minus 6 is a 24. This is a 24xy. Okay. Actually, nothing else changes, so I'm not going to go back and redo this entire problem. But now I'm going to see if I can simplify. Now, I actually can't simplify. I can see that at this point, but it's not super obvious. So let's factor out the top. I can take a 2x out of the top, and that leaves behind an x plus 12xy. And then I can now see that nothing else can cancel. But I wasn't extremely confident, so I took the time to factor out the top to make sure I did not have any common factors. If you had circled this, that would have been perfectly fine because they're both simplified fractions.